Here we have the robotic arm from the previous problem as shown. Assume that theta is currently 30 degrees and that point C lies along the x-axis. The question is, what should the rotational velocities of links AB and BC be in order for point C to have a velocity of 1 foot per second to the left? Let's designate rotational speeds of these links as theta dot for link AB and phi dot for link BC. I use the Greek pronunciation phi since this is not an English character. So let's begin by writing x and y coordinates of point C in terms of the geometry. X sub C equals to 3 cosine of theta plus 2 cosine of phi. Y sub C equals to 3 sine theta minus 2 sine phi. And for the position shown, y sub C is 0. So I can use this equation YC and plug in angle theta and solve for angle phi. If I take this equation and write 3 sine 30 minus 2 sine phi equal to 0, I can solve and get phi for the position shown as 48.6 degrees. Now let's take time derivative of these two equations and find x dot of point C and y dot of point C. X dot sub C equals to minus 3 sine theta times theta dot minus 2 sine phi times phi dot. And since this is the same as VC, we can let this to be equal to minus 1 foot per second. Then we can take derivative of the second equation, y dot C equal to 3 cosine of theta times theta dot minus 2 cosine of phi times phi dot. And since point C is moving horizontally, this equals to 0. So basically at this point I have two equations with two unknowns, which are theta dot and phi dot. Therefore, if I plug in the numerical values for the other parameters, we can solve two equations for two unknowns. That's basically what the rest of problem boils down to. So let's continue and plug in the values. We have minus 3 sine 30 times theta dot minus 2 sine 48.6 times phi dot equals to minus 1. And the second equation, we have 3 cosine 30 theta dot minus 2 cosine of phi, which is actually 48.6 times phi dot equal to 0. If I simplify equation 1, I will get, let's see, simplify equation 1 and solving it for theta dot, I will get theta dot equal to 0.667 minus phi dot, and equation number 2, if I simplify and solve it for phi dot, I will get 0.5092 times phi dot. So I can plug in this fourth equation into number 3. If I do so, I will get 0.5092 phi dot equal to 0.667 minus phi dot, not theta dot but phi dot. So this equation will give us a numerical value for phi dot as 0.442 radians per second. And then if I plug this into the fourth equation, equation number 4, I get theta dot equal to 0.5092 times 0.442, which gives us phi dot equal to 0.225 radians per second. So these are the two rotational velocities for links AB and BC.